Cool. So we'll talk about the code for getting a single credit card's info from an API. So I'm going to focus just on one call that we had to make and some of the issues we had, how we solved this problem. So the outcome should be how to cope with a badly designed API in React Redux code, but also more broadly, thinking about what sort of projects Redux is suitable for and when can it make life painful, what can you do about it, and whether there's alternative tools that maybe you can use. So an overview, what was wrong with this backend API? It was built by internal bank devs. That's not what was wrong. I'm just giving you a bit of context just to clarify that. So it was designed as quite a thin sort of RESTful wrapper around a third-party data provider. That third party actually stored the credit card data. So to get the data for a single credit card, there were 6 different services, like endpoints provided by this third party. And what the backend devs did is they just made 6 endpoints for the app to consume, rather than just making one that the front-end app could then consume. They sort of just wrapped this third party. So the front-end app had to make 6 calls just to get enough data to show one credit card. So the complexity was essentially offloaded to the front end. So why not solve this problem in the backend? Ideally, we would just refactor the backend endpoints, and that would be a good solution to this problem. We couldn't do that, so the internal backend team built most of the API before we arrived on the project, and refactoring would have meant a lot of rework that was going to compete with some upcoming work. So they had a lot of bugs and a very difficult debugging environment. So they had no access to their own staging. They didn't have any backend tests. And they were very siloed with their own microservices. So in the amount of time we had in the project, I don't think it would have been realistic for them to refactor their endpoints in the way that would have been ideal. They also had a custom security layer for accessing all their endpoints. So it was a little bit political to get them to refactor 6 endpoints into one, because they had their own security team that was a bit sort of difficult to deal with. So I'm going to give a really quick overview of Redux and Sagas. I know it's annoying if you already know how these things work when people talk about basics. So I'll try and get through it pretty quick, because some people won't be so familiar with Redux, and those that are might not have used Sagas before. So quickly, what is Redux? Centralized state for your React application. A few benefits is that each component can connect its props directly to the central state. So a problem you might have with just using React is that if you have a component and you want to make its state available to some distant child, you have to pass it through multiple levels of intermediate components via props that don't actually use those props. So Redux can help solve that problem for you. Another thing is that each update to your state is logged in a single sequence of actions. So the debug tools are really great. You can see every state change that's ever happened in a really simple sequence. You can do time travel debugging, so it's pretty cool. So how does Redux update state? It updates your state with what they call actions, and they're just JavaScript objects. So this is an example of an action. It has a type, get data. And actions are a bit like events. They're just dispatched from your components. So where are they dispatched to? So a component will dispatch an action to a reducer. A reducer is just a really simple switch statement. It says, if the action type is like get data, then I'm going to update the state in a certain way. It's really not very complicated. So when it receives that action, it will then, in this case, let's say, add a loading flag to the state. So we know that we want to get some data. So the reducer will say, I'm going to add is loading data true to our centralized state. Now that that's changed, the state can update components via props that need to change. And then the components can re-render and show maybe like a loading spinner or something like that. So what is a Saga? It's Redux middleware. It allows us to kind of trigger asynchronous side effects by dispatching actions outside of this sort of cycle. So the main thing, for example, is network calls to our API. So here's an example of how that works. Again, let's take the same action we had before. Get data. In this case, it's also sort of picked up by the Saga, which is listening in to every action that's dispatched. The action still goes to the reducer just like normal, and it will update your state in the normal cycle. But Sagas also get the action sort of off to the side. So it's listening for the get data action in this case. And when it gets it, it starts a side effect, an asynchronous network call to our API without disrupting the normal flow of reducer to state update to component. So what this is going to do is make a call to an API and try and get some data back. Just does it asynchrony, wait for results, and then it will dispatch an action back to the reducer, back to the normal synchronous flow. So in this case, the action is get data success. In the response key, it will add the actual response we got back from our API, and then it goes to the reducer as normal. So what's going to happen here? It goes to the reducer, and just like normal, the reducer sees that it has the get data success action, and it will update the state with this data in a normal synchronous way, like it normally does, and that will then update the components. So what does a saga actually look like? Well, first of all, at the bottom, you can see how actions are kind of intercepted. So in this case, it takes every get data action, and every time it sees it, it calls the get data saga, which is just a generator function. The Saga library has what's called effects. So what you can see is there's a function called call. This is imported from the Sagas library. All it does is perform a normal network call, and the yield returns the result when the promise resolves. It's a bit like using async await, but it's like generator function syntax for those that aren't familiar. Then there's this effect called put, which just dispatches an action to reducers. So in this case, once our call has returned, it does a put for get data success, and it includes the data that we've got back. Cool, so that's the overview. I hope that didn't go on too long. So to recap, this is going to be a case study about getting card details from an API. What we need to do is make 6 calls in a chain to get this credit card information back from our API. It's going to be one call after the other, because each call depends on the last one. So maybe one call would be get the credit card number, the next one is to get the CVV based on what we've got. And we're going to be using sagas. So some requirements, what we have to do. Each call is used in many parts of the app, sometimes by itself. So we do need one saga per call. But sometimes it's going to be as part of a chain. We're going to have to make a lot of calls at once, which means chaining each of these sagas together in a sequence, one after the other. So why is chaining sagas painful? It is quite painful. This is just really simple vanilla asynchronous code. It's really easy to call this in a chain. It just returns and throws an error if it has an error. So if we want to chain this together with another call, it's really simple. You just put it in a try-catch. It's just a couple of lines. We've got example call that you saw on the previous slide. It returns its data. If it doesn't throw an error, it will then move on to do next call. So it's pretty easy. Here is an example of a saga. So I think the main reason that chaining sagas is painful is because actions are fire and forget. So sagas don't return anything, and they also don't throw errors. They just dispatch actions. So in this case, we do the same call, but rather than returning the result, we put this action. We say success, and then that action will save that data in the store. And if we get an error, again, we just dispatch an action that's like error, and that then goes to the store, which can make life slightly painful. So here's an example of trying to chain the last saga you saw in the last slide with another one. So in this case, we do this yield put, which sends off an action that will trigger the saga that performs this call. What we then have to do is, so the saga will handle success and failure in a try-catch block, and it will add data to the store for success or trigger a failure action. But you can see what this means is that we then have to actually try and check and see, did we get success or did we get a failure action? So we try and take either success or failure. In this case, if success happens first, it will take that. If failure happens first, it will take that instead. Then we have to check the result and see if it was a failure action and throw an error if we do. Only then, if we haven't thrown an error, can we do the next call. So you can see that this is a lot of code. It's like very verbose. It's not very clear. Yeah, it's not great. Again, to compare the exact same thing just to vanilla async JavaScript, this is a lot nicer. So why are sagas so painful? And what can we do about it? So one thing that we can do is use an effect called race. So in this case, we have the same chain. We try and get the card number, but this time we only wait for success. The problem with this is that if we don't get success, if it has an error in the call and it then sends off a failure action, that success will just hang forever. It'll never be taken. But that's where race can help you. So race, it starts a race between that chain function and taking any kind of failure action. So if it gets a failure action before that chain is completed, it cancels the chain, even if it's halfway through. So we don't get any kind of memory leaks or anything like that. But it's still not great. It's kind of a bit implicit. And if you're not that familiar with some more unusual effects like race and sagas, it can be a bit confusing to understand what's going on. So another thing you can do is kind of create these sort of pseudo sagas. So in this case, what we have is a saga which actually throws an error. This means that you can't trigger it via an action because actions are just fire and forget. And if it throws an error, it's not being caught by anything. So it can just throw your error out. So it has to be called just like a normal generator function. So we've made kind of a saga which is really just a generator function. And then just below, we call it from an actual saga, which is listening in for this get card number request action. That's when it knows to start this call. And so this is what the code looks like if we want to chain some sagas together. It begins to look a lot more like the asynchronous vanilla JavaScript code. All we do is a call to get card number service, and then a call to get CVV service. If get card number service fails, it will throw, and we'll never get to get card CVV, which is sort of a bit more like normal JavaScript code. So the chain's been simplified quite a lot. So I think one thing that comes to mind is like if this is all just crazy, that's quite a lot of things we have to do to make our code less complicated. And it kind of made me think, when are some times when using Redux and sagas can actually cause you more pain than doing something a lot simpler? So just to kind of recap, what is the boilerplate just to do one network call, regardless of whether or not we're chaining anything together? One network call using sagas. I'm going to go through this quickly just to illustrate how much it is. So you've got to make an action creator in some actions file. You've got to have a request action, a success action, a failure action. You've got to add constants to a constants file for each of these. You've got to add typing if you're using Flow or TypeScript for each action creator. You've got to make an API call service to actually call the endpoint. You've got to make a saga for the call. That calls the API service. Try catch dispatches success, or it dispatches failure if something's gone wrong. You've got to add that code to receive the action in the reducer. Set is loading to true for request, false for success/failure. Set data property to the success. Make a container component to wrap the component that needs the API call response so that you can actually give it as props. Use connect, map state to props, props to add to component, type check is loading data. So this is quite a lot of boilerplate. And at some point you say, is this actually worth it? And in what cases is it really worth doing? So here's a quick comparison to using just the normal React context API, which I think in some cases can replace your use of Redux. So this is a context provider. I think it can replace the Redux state. In this case, if we want to make a call, we just have a method to do it, fetch data. And in its set state, it can set a loading data flag to show your loaders and things like that. And in value, we can export that data out so it's accessible to consumers. Here's an example of a high-order component. We can wrap any component in this and give it all of the data from our context provider. So it's pretty straightforward to do. So we do with data and component. So Redux versus the context API. What they can both do for you, with Redux, you can connect each component to a central state directly, so not having to go through passing props through every single parent and descendant. Context API, you can do the exact same thing for a provider, so it serves that purpose in both cases. With Redux, the really nice thing is that each state update is logged in a single sequence of actions. So the debug tools are just really good. If you have a very stateful, complex app, I think that it's probably worth using Redux. Whereas with context, there's just far less boilerplate. There's no actions, containers, reducers, sagas. You can save yourself just a lot of typing and some of the complexity that you saw there when you have weird problems. So I think, when do you actually need Redux? I've used Redux in quite a few projects. I've used the context API more recently. So I've had a bit of a think about when it's been useful and when it's been slightly more painful. I think using Redux is a good idea if your app has a lot of pages that are only accessible under certain conditions. So to come back to this case study, like, why was it a good idea to use it in this banking app, which I think it was. It had a very complex multi-page onboarding flow. So if you were to make a flow chart of how do you get through this onboarding flow, it's pretty complex. There's a lot of branches based on a lot of state. So there's different subpages. It kind of depends on, are they a pre-existing banking user? Do they use other banking apps? Do they have ID verification issues? There's a lot of different times when a page needs to be made accessible. So it's very stateful routing. And I think the Redux debug tools were kind of a lifesaver to sequentially show how state changes are happening, and we can debug much more easily. But no, if your app just has two user roles, logged in and logged out, and the pages are mostly accessible for any logged in user. I think this is an app which is simple in, it's not very stateful routing, so it might, in some cases, be a bit overkill to use Redux. Another thing where it's clearly a good idea to use Redux is if your app is kind of like a desktop-like app, like something like Google Sheets. Very stateful. There's a lot of front-end data processing, so we don't offload that much to the back-end. But no, if most or all of your data is in your state via asynchronous calls, so API calls, disk reads. If your app is like a nice UI for just doing lots of gets and posts, and it has a lot of offloading to the back-end, I think API calls are probably the #1 thing that Redux can make more complex, a lot more boilerplate. So if you're only using it to dump things that you get back from API calls, there may be a simpler solution. It might not be worth doing. So I think that's it from that case study. Thanks, guys.